Welcome to the October Public Global R&D, or sometimes we call it YouTube Global R&D because we publish it on YouTube. Welcome ICP community, welcome DFINITY team. My name is Sam. I lead the engineering team at DFINITY, and it's my pleasure to be your MC today. We have an interesting hour ahead of us. We start out with an update from the growth team about a library they created. We allocate quite some time for mainnet load and some specific improvement we did. We get an update on boundary node, a key aspect of decentralization. Every month we have an update on developer experience, so we get that from Jason. Hear about a new library to managing cycles, and then allocated quite some time for community demos. The first one is by NFID on Identity Kit, and then Primevault, a Fireblocks challenger. So let's get into it. Christopher, you're up. You have worked on IC Alloy. Over to you.
Thank you. Yes, so my name is Christopher. I work with the growth team, and we constantly try to provide tools, examples, templates, etc., to make the developer experience more create a nicer developer experience for developers out there. And this time we took on the developer experience when interacting with the EVM RPC canister. So we created IC Alloy, which is a fork of the well-known and established library Alloy. It's a Rust-based library that allows you to interact with the EVM RPC and provides really good typing, etc. So in our case, we believe it radically simplifies interacting with the EVM. It's sort of an abstraction layer on top of the EVM RPC canister. And since Alloy is an open source project, we also, of course, published IC Alloy as an open source project. So on the next slide, please. So this is currently how it looks when you want to create a transaction from a Rust-based canister. You set up the transaction, you sign the request, and there's it's kind of verbose, one might say. It's not necessarily complicated, but verbose, and we thought it would be a benefit for developers if we could make that whole experience a bit simpler, sort of. So move on to the next slide, please. Using Alloy instead, this is how it looks. So like I said, Alloy provides this abstraction layer on top of the EVM RPC RPC canister. It provides types for signers and for providers. So basically, we use ICP as a transport layer initially, and we also use the signer abilities of ICP to sign transactions. And once we hooked up the Alloy library with the signer and as a signer and as a provider for ICP, we get all the benefits of using Alloy, which means that all the complexities of interacting with the EVM is hidden away for developers. So basically, to send an Ethereum transaction from a Rust-based canister, in this case, you would only import or initiate the contract from the ABI, from the JSON-based ABI that you can download from Etherscan. You see on the top line there, we initiate the USDC contract with the address and the provider that we set up earlier. And once you have the contract initiated, you have a fully type-safe methods to interact with. So in our case, we interact with the contract.transfer, and we submit it with a nonce. In our case, in this example, I used some manual nonce handling, but you can also do the fully automatic nonce handling. So that is something that Alloy provides. Is you can what they call fillers, so that they do automatic nonce handling, automatically looks up the chain, automatically does gas estimation. So basically, doing all the messy stuff with interacting with the EVM, they do it for you. The downside is that it leads to quite a fair number of requests to the RPC. So you run the risk of hitting the API limits when running the EVM RPC canister on 34 nodes at the same time. But other than that, it's a great idea. So yeah, to sum this up, Alloy comes with great typing, a good developer experience leads to happy developers and hopefully new fantastic projects. And Alloy also comes with loads of nice utilities from everything for handling Ethereum-based data types. And next slide, please. And so far, what we have published and deployed is there is of course the GitHub repository and the library. It's not published to crates.io yet, but will be soon. There's a docs website. There is a wallet demo that you can look at and use as a template for setting up a multi-user wallet. And there is a toolkit demo just demonstrating all the bunch of various ways of interacting with the EVM, such as getting the balance, transferring a token, signing a message, etc., etc. And that's it for IC Alloy. I hope it will make developing Ethereum-related apps on IC easier. Thanks.
Sam, I think you're muted.
Thank you. Thank you very much, Christopher. That fits very nicely into the chain fusion narrative. Next up is now Manu and André. The community has certainly felt quite some stress or challenge during the last few weeks because there was a heavy load on the IC and some subnets that led to very poor user experience. There has been some improvements made, which is a great relief. And the foundation has proposed some changes that are now being discussed. Manu, you tell us more about this, and then André talks about the specific improvement that was very helpful. Over to you, Manu.
Yeah, thank you, Sam. Yeah, exactly. So there was high load on mainnet in the past months. It grew spectacularly. You can see it from this chart here. I mean, we had something like 7x the instructions processed on the IC overall, which is fantastic news, of course, right? We all want ICP to be used, so this is really great, and we're very excited to see this. But as Sam hinted at, this also came with some growing pains, I guess. So it wasn't as smooth as we would maybe have hoped. And yeah, we're going to talk about now what we propose to do is next immediate steps and maybe more midterm changes. And so let's start by looking at the timeline. So what we saw is that different subnets started receiving more messages to process than they could compute. And that means that messages end up in queues. They need to wait a little bit for their turn, leading to increased latencies, or even they would time out. So they wouldn't get their turn before the expiration of the message. And what we see here is a chart that shows for every subnet, the fraction of the ingress messages that timed out waiting for execution. And so what you see on the left is that typically this is 0. And then in the middle of September, we all had a lot of fun with Bob.fun, which put a lot of strain on 2 subnets. So we suddenly saw messages expire on those subnets. And then throughout the second half of September and October, we saw a lot of load on other subnets as well, which I think stems mostly from a lot of heartbeat canisters, which try to process messages every round and thereby add a lot of strain on the subnets. So especially during that time, there were a lot of issues on like 10 subnets. And then in the middle of October, we proposed a new replica version that handled the load significantly better. So then you see that on the right, essentially the timing out ingress messages are back to 0. However, we still see increased latency, so we're not completely out of the woods yet. But I think this gives you an overview of the how things were in between and that they are much better now. So we still want to do a lot of next steps to further handle this load better and lower latency for everybody. And the first is more replica improvements. So we saw on the previous slide that this one replica improvement made a huge difference and made things much better. And we have many ideas, more how we can improve things. And that's going to be the next section that Andre will talk about in more detail. So I'm gonna skip that here. Then another next step is that we want to remove SNS heartbeats. So as you probably know, heartbeat is this functionality that lets your canister basically ask to execute every single round. And that's a very cool feature because your canister can now do stuff completely on its own. It can run like a cron job. It can do its own stuff without needing to be triggered from the outside world. However, it's also quite wasteful, or it can be quite wasteful because your canister literally asks to execute every single round, which might mean it actually is invoked and executes a message 30 million times a year. That's really a lot. And so this puts quite a lot of strain on the subnet and is often not what you need. And so later we added canister timers, which allows similar functionality. So it allows your canister to be woken up on its own and do stuff on its own without external triggers. But now it can specify like when it wants that to happen. So you can do it much more granularly and thereby also put much less strain on the subnet and pay fewer cycles. And now the issue we saw is that there were hundreds of instances of the SNS canisters being added on subnets. So these are not SNSs that went through like a decentralization sale, but they were just instances of the canisters that people used. And they all had heartbeats. So this added a huge amount of heartbeats on many subnets, thereby adding significantly to the mainnet load. And what DFINITY has been working on is creating new versions of the SNS canisters that now don't use heartbeats anymore, but use timers. This work is done. And so now we need to make sure that all the SNSs that actually run are upgraded. So we ask everybody's help for that, but we think this would help a lot and both help reduce load and for people to reduce their cycles cost, which is also interesting. Then talking about cycles costs, the idea is, of course, that whatever workload you run on the internet computer will put a certain amount of strain on the subnet and cost cycles accordingly. However, we saw, and the community saw, that for certain types of workloads, this is actually not the case. And there was a motion proposal to suggest that we modify that to increase the cost of certain workloads and to make it more in line, that the load on subnet and the cost is in line. And so DFINITY now took that proposal and made it concrete, which we put on the forum last week. And so the concrete proposal that we have is to increase the computation base fee, which is the fee that you pay every time whenever your canister processes any message, whether it's an ingress or a crossnet or a timer or a heartbeat, increase that from like 0.6 million to 5 million. This sounds like a big change, but this means that your canister can now process 230,000 messages and the increased cost would be 1T. So like $1 and a bit. But this kind of targets the things that we saw were undercharged in the past months. Separately, we propose to increase the cycles per WASM instruction from 0.4 to 1. This in line with that motion proposal, and the canister creation fee from 0.1T to 0.5T. Here it's important that if you create canisters from another canister, you need to make sure that you attach enough cycles when you create canisters. Otherwise, when this change would become active, those calls would start failing. There is a forum link here that goes into a lot of detail about how we got to these numbers and concrete examples. But just to give you a little bit of an idea what this means, we took some of these templates, these that we have in this ICP cycles cost calculator that we released recently, and analyzed what they would cost now and if we would go ahead with these changes. And you see like a moderate increase. And that's because we only increased some dimensions, but a lot of things stay the same. So overall, it's not that impactful. And it's important to note that that one thing, the second thing where you see the biggest increase, that's actually mainly a one-time cost increase, not a periodic cost increase. So it's mainly due to the cost, the canister creation cost, not the per year cost after that. Then, as a next step, DFINITY submitted a motion proposal to adjust the target topology to add 20 app subnets. So we have this target topology, which is updated via motion proposals, which I guess is our agreed upon target and what we use to see if we need more nodes or not. And so DFINITY now proposes to change that to add more subnets, which would increase the capacity of the internet computer. Also there's a forum thread that you can check out and join the discussion. And this proposal is live now, so you can vote on it if you have an opinion on it. And this brings us to the next part. So there's all this mainnet load now, but it also asks the question of like, how does ICP scalability really work, and are there issues? And so I think as a summary, the idea of ICP is that every subnet has, of course, a fixed capacity. There's only so much it can do, but ICP can always grow its capacity by adding more subnets. And every added subnet grows the capacity of what the internet computer as a whole can process. And then the idea is whenever something gets overloaded, somehow there's some load balance, and this spreads over the subnets. What we now, I guess, see in this growing pain is that this load balancing is the weakest point in the story. So we now see that some subnets are loaded and others are empty, but it's hard to load balance. There is some support for subnet splitting, which would take one subnet and split it to become two subnets that now divides the load over these two subnets. But there's, I guess, practical concerns with that, mainly that canister co-location is important, and it's difficult for the NNS. It's NNS driven. It's difficult for the NNS to find a good way to split. So that's not ideal. And so DFINITY therefore thinks that like in the midterm, the most important thing we need to do is support canister migration. So allowing a canister controller to move a canister from one subnet to another without changing the canister ID. And then the scalability story would be whenever a subnet is full or heavily used, it burns a lot of cycles. So we're all happy. We can add a subnet that opens up new capacity, and people can move there and are not on an overloaded subnet anymore. And as a side benefit, I think this will enable much better subnet utilization because this would allow, like a subnet has different resources. It has compute capacity and storage capacity and consensus bandwidth. And if you can move individual canisters, we can nicely put things together such that we expect to see that all the different resources are nicely used, whereas now we see that a lot of subnets are purely compute bounded, while others have a lot of storage, but it's not nicely spread across the subnets. And this is a good thing for cycles burn overall, so in the interest of everybody. Also, here's a forum link with a lot more details. I welcome everybody's input in the discussion. And then I hand it over now to Andre, who's going to talk about the specific replica improvements.
Hello everyone. I'm Andre from execution team. I'll go into more details on scheduling improvements. We already know what happened. Probably the most noticeable issue for users was the expiration of ingress messages, which are messages sent directly by users. Let's jump into why it happened. To guarantee the worst case execution latency, our scheduler uses compute allocation. For example, 10% compute allocation guarantees that the canister will be scheduled at least 10 times in 100 rounds, or roughly every 10 seconds. But because it's a hard guarantee, it's costly, and we didn't have much load, so most canisters on the mainnet have zero compute allocation. As a result, we schedule those canisters round robin, and the scheduling order doesn't change much. On top of that, when one canister is scheduled but it has no messages to execute, another canister takes this opportunity and gets executed instead. And those opportunistic executions were completely free. During the past few weeks, we worked hard to improve our scheduling and sandboxing. And to give you some context about the load we faced, here is a graph of non-idle or active canisters on the subnets. Those are canisters actively seeking to be executed. In September, the number has increased from less than 2K to more than 30K canisters. On the next slide, please. Let's have a look how our scheduler worked before the improvements. In the image below, say canister A has the highest accumulated priority, so it's scheduled first on the execution core. Say the canister is idle, it has no messages to execute, so it just gets penalized and goes to the bottom of the schedule. While the next active canister is in the schedule is opportunistically executed instead. In the worst case, right in the next round, canister A receives a message. But now to execute that message, the canister has to wait a few rounds, accumulating its priority until it gets to the top of the schedule to be executed again. On the next slide, please. Let's see how the scheduler works now. Just like before, canister A is scheduled first on the core, it gets penalized and goes to the bottom. The next active canister is executed instead. But now this opportunistic execution is also penalized, and all fully executed canisters go to the bottom of the schedule. Again, in the worst case, canister A receives a message right in the next round. The canister still has to wait until it gets scheduled again, but because now we penalize way more canisters, the delay now is significantly shorter, while preserving all the scheduler properties and guarantees. Unfortunately, once we released the scheduling improvements on one of the subnets, the finalization rate dropped there, and we had to roll the changes back. Yeah, thanks. There is a graph of the sandbox processes spawned per second on that canary subnet. We use sandbox processes to securely execute canisters. We spawn an isolated sandbox for each canister, but then we terminate and evict the sandbox to free up memory. With the new scheduling improvements, we execute more different canisters each round, spawning way too many new sandboxes, which was the cause for the performance degradation, and that's the first spike in the graph. So to make it all work, on top of the scheduling improvements, we had to look into sandboxing. We made some quick changes there. We released the changes again, and so far so good. But our team's main focus probably for the next few weeks is to improve the sandboxing to the point so we have some safety margin and a peace of mind. Which brings us to the results. On the next slide, please. There are two graphs. At the top, there is the same graph we saw previously. The number of active canister has increased and it stays at this level. At the bottom, there is the number of expired ingress messages per second, which is the biggest concern for our users. This metric was roughly 0 before September, and it's roughly 0 now after the scheduling and initial sandboxing improvements. On the next slide, please. There is a link to the forum post with a great amount of details. Stay tuned for more improvements, and thanks a lot everyone involved. We did it together.
Cool. Thank you very much, Andre and Manu. And while we here talk about all the problems, I think it's in a way also a nice problem to have. So there was all this load, so the IC is being used. And I think that's very much in the interest of everybody who puts their heart and a lot of good work into the IC. So thanks for getting the IC out of this challenging phase. And please, community, get engaged, join the discussion about these changes that we have proposed. Next up is Rudy. You talk about, boundary node decentralization.
Yes, exactly. So I want to explain you today how we propose to handle incidents with the upcoming boundary nodes, the API boundary nodes. But before we get into that, I just want to quickly update you on where we stand today. So I'm happy to report that all the main components of the new boundary node architecture are actually done. We have on the right IC boundary, the core of the API boundary nodes, which has been running in prod for a year now. IC gateway, on the other hand, or like on the left side, is the core of the HTTP gateway. It has been running in prod for several months, and the discovery library is currently being integrated into Agent.rs, and this is kind of the glue between the HTTP gateway and the API boundary node, or just the library that helps clients to find the API boundary nodes and route requests to them. And now we're in the final phase of kind of getting ready for the rollout. And for this, we also need to start thinking about how to handle incidents. Next slide, please. Now, obviously, the goal is to not have any incidents at all, but we know that this, the reality shows there will always be some incident, and for this, we have to be ready. Now here today, I will just give you a very high-level overview of what we propose to do. And for the details, you can check actually the forum post that I linked with this QR code on this slide. And you can see also the proposal that I'm just explaining now today a bit as an extension of the existing security patch policy and procedure, which has been adopted in March 2022 by the NNS, which has back then not yet encompassed the API boundary nodes. And when we talk about incidents from the perspective of the API boundary nodes, we have kind of two situations. One, when the API boundary nodes go down, and the other situation is more when another component of the IC is affected and the API boundary nodes can step in and help mitigate the issue or help resolve the incident. So first about API boundary node recovery. Now, all the requests to the IC go through the API boundary nodes. And if they all go down, how do we propose to roll them back? How we vote on that? This is what we have to address. And what we propose is to allow list specific IP addresses that then allow us or allow to spin up voting boundary nodes with these IP addresses. And this would kind of allow voting out of band, voting around the API boundary node. And the second part is a bit more sophisticated or intricate. So this is just that whenever some component is affected, the API boundary nodes might be able to help because they can apply limits or filters on the incoming requests. And for this, we propose to set up a system canister that hosts these rate limiting rules, and the API boundary nodes will pick them up and enforce them. And more details on that I have on the next slide. So I can provide you some context. We had some incidents in the past where we had to set up rate limits. One of them was the memory leak incident in the ICCDK, where we protected some vulnerable endpoints on the SNS canisters until the patches have been rolled out. Now, back then, it was quite straightforward for us to apply the rate limits because the DFINITY Foundation is in control of the old, like the legacy boundary nodes. But with the NNS managed API boundary nodes, this won't be possible anymore. And to this end, we propose to create this canister, as I mentioned before, which kind of just acts as a rule storage. This canister will be obviously NNS controlled, and through the NNS, one can authorize principals that are allowed to insert rules. The API boundary nodes then periodically fetch these rules and enforce them. During the incident, the rules have to be kept private, but after the incident is over, as part of the post-mortem, they will be disclosed. Next slide, please. So as you can see, this was really like a very, very quick overview. And if you want to know more, check the details. If you want to provide feedback, ask questions, please check the thread in the forum. You can use the QR code on this slide, the top one. And in a while, we will submit the motion proposal with the approach that kind of results also from the discussion on the forum. And if this is then being adopted, DFINITY will submit two types of proposals. One to allow list the DFINITY IP address for a voting boundary node. And the second would be a proposal to set up the system canister and to authorize the DFINITY principle. So yeah, if you want to know more, want to provide feedback, please check out the forum post, vote. And with that, back to you, Sam.
Thank you, Rui. And by having that implemented, we will be one step closer to having a truly decentralized system. So very excited to also solve this boundary node decentralization challenge. Next up is Jason. As every month, we talk about developer experience, because ultimately, if the developers are happy and enjoy building on the IC, there's more adoption for ICP, and that's why, to make this really explicit, we talk every month about some developer experience improvements. Sometimes they're very small, but we still hope and want to signal that this is front and center. And with that, over to you, Jason.
Thank you, Sam. Hi, everybody. I'm Jason from the Developer Tools team, and I'm back this month to give you another update on developer experience. I'd like to talk about an upcoming milestone launch and then get into a couple new enhancements we've shipped for developers in October. But first, let's get into some metrics. Next slide, please. So here's a chart of the activity on the developer experience feedback board since the past summer to now. Overall, the activity has been generally constant. We can see a number of issues get created in September, and then a response to that in October with a few issues closed or set to in progress. We actually saw no activity on DX issues in August, and I suspect that's likely due to folks taking their summer vacations. Overall, though, the activity looks good, although I would definitely like to encourage more people to go to the feedback board. And don't leave until you've voted on a topic or created one yourself. And there's a QR code you can scan that will take you right there. Next slide, please. So next, I'd like to talk about the upcoming Beryllium milestone. I've talked about this before, but now we're very close to Beryllium launching officially. This milestone includes 4 features that aim to improve DevOps on the IC. And I'll summarize each of those here for you. So with state snapshots, developers can take a snapshot of their canister state, and then they can perform experiments with more confidence, knowing that a failed upgrade or buggy code can be quickly rolled back to the last saved version. With logging, developers can fetch the logs that their canister produces while deployed in production, and that includes error messages within traps. So this is helpful for debuggability. Backtraces then build on top of the logging experience by providing insights into the code that caused the error. So that includes the full function stack trace all the way down to the offending line, again, helping with debugging. And then finally, with standardized error response codes, developers can code more predictable journeys into their applications, such as offering graceful degradation and finer grained sad paths or happy paths based on the response code that's coming back. Next slide, please. So the Beryllium milestone will officially launch next month. It's going to bring a number of great features for developers. And of course, there's plenty more to come. So stay tuned for the announcement. We're going to have a number of activities surrounding it. We'll have an X space and some communications. And there will be other exciting news around it as well. So please stay tuned. Next slide, please. So a couple more things. In addition to everything you just heard, we also shipped a couple other enhancements that some of you in the developer community have asked for. Next slide, please. So first, we now support an allow list to access canister logs. Previously, only controllers could fetch the logs. So now with this, it should be much easier to collaborate and distribute work across teams. Quick note that a controller access is still required to modify the allow list. So yeah, some of you have asked for this feature, and this is a response to those requests. So thank you for those who brought this to our attention and asked for it. It's available now. Next slide, please. Second, we've addressed referential integrity within actors. And so, what does this mean? Previously, it was not possible to reference self within the actor body of Motoko program. This actually turned out to be a bug. So there's a code snippet here that shows something that seems like it should work, just really determining what the canister ID is of the actor, but you can't, previously you get this error, cannot use self before self has been defined. This turned out to be a bug, so big thank you to the person who flagged it and to Gabor from the Motoko team for implementing the fix. This will be available in the next version of DFX 024.2. And so with that, that's it from me. See you all next time and have a good time building.
Cool. Thank you, Jason. And with this, we now move over to features, and we have Jan who talks to us about Canfund, a cycle management library. Over to you, Jan.
Thank you. Hi, so my name is Jan. I'm from the product enablement team, and I want to talk a little bit about Canfund, which is a cycles management library written in Rust. And as you likely know, other tools for cycles management like CycleOps or potentially different. Let me tell you a little bit about why we built Canfund. So on the next slide, please. So Canfund actually comes from Orbit. In Orbit, every user can create their own station. Alongside with each station, there is also an upgrader, which takes care of the life cycle of the station. And you can also link other canisters to a station for each user. So the station itself, as it is also a wallet, needs to top up itself to have enough cycles, but also needs to top up upgraders and potentially also the linked canisters. And this is exactly where Canfund was born, and as there was no Rust solution at that time, it was really developed as part of Orbit. And we also see there were other use cases outside of Orbit, so we decided to extract it into its own standalone library and open source it for everyone to use. It's not a fancy library with a UI and crazy features. It's really like a very lightweight, very customizable library that everyone can use if they have a similar use case, and should be fairly easy to plug it in. So on the next slide, please, there is a brief list of features what Canfund can do and can be configured into. So first of all, obviously, different funding strategies. So Canfund can, for each canister, configure different funding strategy. It could be based on a minimum runtime, which is calculated from average consumption of the canister. It can also be based on a balance threshold, so whenever the cycle balance goes below, and it can also be periodically funded with a fixed amount of cycles every funding round. Next, there is a balance fetching method, so the way how Canfund fetches the cycle balance for each canister. So generally, the default way would be the management canister, but you can also generally configure any public endpoint on any canister on the network. And you can also fetch it from Prometheus metrics considered. The canister publicly exposes them, and they also contain information about cycle balance. Obviously, Canfund can also min cycles. So when the pool is low and it cannot top up anymore, it would min cycles to replenish the pool again. And lastly, there is also, you can also leverage callbacks for the funding rounds. So this is very useful for setting up alerts, metrics, or notifications for any of the data that Canfund holds. So that could be the cycle balances of canisters, that can also be the top-ups or the average consumptions of the funded canisters. So the next slide, please. So what's next from Canfund? Quickly, so obviously we'll be maintaining the library and also extending it with features as we see fit. And we also decided to build a service called Cycles Watchdog that is built on top of Canfund. And it's basically a service to manage cycles for canisters at DFINITY. It is meant to replace an outdated canister monitor app, which is now not maintained anymore, and still responsible for monitoring over 30 canisters on the network. We also aim to fully integrate it with Orbit in a way that Canfund will actually fund some canisters within Orbit, but also whenever the Cycles Watchdog actually needs ICPs to mint more cycles, Orbit can automatically create a request for this and approve it. So ideally, this should be a fully hands-free process with no interactions. So this is it for me. Thanks for listening. If you want to see more, you can have a look at GitHub or Crates.io. And thank you for listening again, and happy funding.
Thank you, Jan. Now we move over to demos, and we first have an update from the NFID team. I guess, Dan, that's you.
Hi, everyone. I am Dan Ostrowski, and it's a real privilege presenting to you today. Some of you may already know I lead the team on the single signature NFID wallet and the multi-signature NFID vaults. Today, though, is all about unlocking network effects in the toolkit we made to make that easy for every ICP developer. Some of you may even know we've been around since Genesis. We've raised venture funding from prominent investors, and we have one of the largest teams building infrastructure on ICP. For those that don't, now you do. But as I mentioned, I do want to focus today on something more practical that we recently dropped everything to tackle. One of Web3's biggest promises is data portability, letting users easily switch between services without losing their data. Imagine Facebook sunsetting a feature you loved, starting to charge, or altogether shutting down. You'd have no way to recover your entire digital social existence. That's not a problem in Web3 because you could just connect to another social service and pick up where you left off, probably also with features only that new service offers. While the ICP network is powerful in many ways, it wasn't originally released with the standards to operate this way, and it's created challenges for developers wanting to tap into the network effect of a growing ecosystem. So to solve this, we partnered with DFINITY and community members like CSnake almost a full year ago to develop a solution. We identified the problem that when users can't easily connect across apps with the same identity, developers struggle to innovate. Apps become isolated from greater network effects, and assets are harder to manage. We identified the need, a low-effort way to support the same identity across apps without sacrificing user security, and a way for new wallets to get ecosystem-wide distribution. And we built the solution. 7 standards wrapped in a convenient plug-and-play toolkit we call Identity Kit. At its core, Identity Kit supplies a Connect Wallet button and modal that dramatically reduces development time and ensures users can authenticate with the same identity across the entire ecosystem. So now let me show you how this works in action with ICP TopUp, a simple tool for quickly topping up a canister developed by our good friends over at Cyclops. The main goal for Cyclops is to authenticate a user, check they have enough ICP to complete the top-up, and request approval to spend that amount of ICP. So as a user, I enter the canister ID and amount I want to top up. Then I'm prompted to connect my wallet, which ICP top-up uses Identity Kit for. They used their own custom button, but kept the Identity Kit out-of-the-box modal. After choosing NFID wallet, 4 standards work in series. 29 establishes a secure connection between dApp and wallet. 25 establishes connection permissions. 34 is the dApp requesting a delegation. And 28 verifies if the wallet can return a delegation for the user's main wallet address. There's obviously too much to explore in the time I have, but I'd like to take a brief side note on by far the most confusing and important aspect of identity authentication on ICP. I've spoken with what must be most of the active teams on ICP, and a majority of them, no matter if they're seasoned or newly entered, simply don't understand delegated identities. And the easiest way for understanding delegations are that they eliminate the need for users to sign every transaction individually. They are to ICP as session keys are to Ethereum. NFID Wallet supports both types: delegations for ecosystem-wide identities and delegations for application-specific principles using the same mechanism as internet identity. Unlocking interoperability and composability on ICP meant being able to navigate the ecosystem as a single identity. So we wrote the standard that allows any signer to do this safely, including internet identity if it chose to. Ultimately, this right here is exactly what application developers want: a way to remove wallet approval prompts to their own applications while still being able to read a user's ecosystem data, like in this case, a sufficient ICP balance. But the opportunities for developers to leverage ICP's open API architecture for a user's single identity cannot be understated enough, in particular because of the wealth of data that can be stored on this network. Of course, taking action on my ecosystem data, like moving money, does require individual approval. So ICRC 49 is the bread and butter standard to request users execute calls to other canisters, like in this case, ICRC2 approve on the ICP ledger. This standards project started nearly a year ago, and now all major wallets either support it fully or are wrapped to ensure compatibility. As new wallets like Oisi and Primevault join the ecosystem, these standards will help them more easily gain adoption across all applications. As for apps, many of the ecosystem's largest have already adopted or are in the process of adopting these standards, building a stronger, more connected network of powerful applications. For anyone who wants to get involved in development of the standards or the toolkit, here's the list. On the standard side, browser extension wallets like Primevault and Plug are using custom channels. We need one or suffer fragmentation. We need a discovery standard for which we have a draft proposal, and a standard for mobile wallets like Biddy to connect with ICP apps. On the toolkit side, IdentityKit needs to build out a common JavaScript engine that other frameworks will be built around. We're very thankful that the Water Neuron and Bionic teams are already helping us on this effort. And finally, a message to all the application developers out there wanting to take advantage of the network effects on ICP, join our Discord, and let's get building.
Thank you, Dan. It shows how standards enable interoperability and create the thriving ecosystem. It's very motivating. Thank you. Then we come to the last demo for today, and that is from Primevault. Primevault is a Fireblocks challenger and has worked on integrating with ICP. And I guess you give us an update on how this is going. I guess, Akansh, it's you, so I hand over to you.
Thank you so much, Sam, and thank you so much, Dan. As Sam mentioned, I'm one of the co-founders of Primevault, and we're super excited to be presenting today. As Sam mentioned, we're a Fireblocks challenger, or a lot of our customers say Fireblocks killer. We're essentially an institutional infrastructure play for institutions to access DeFi ecosystems like ICP. A quick background about us, we come from a deep fintech experience. We worked at, the founding team of Rippling, which is a $15 billion company today. We have chief security experts today on our team, and we're backed by Y Combinator and a bunch of top funds like Arrington and Hashkey. But what essentially is Primevault? We're at the core of it. We're an institutional infra company where institutions can custody their assets or self-custody their assets. We give like deep sort of control in terms of the policies and the risk measures that you have. But what we've actually done is we've innovated on the kind of things you can do with your assets. So we actually built inbuilt automations. So for devs, if it took like say a few weeks, you can actually automate anything within a few days when it comes to token operations. We're the fastest in the market when it comes to integrating new chains or new dApps. One thing which we allow is for deep liquidity. So we actually aggregate liquidity across CeFi and DeFi, which means you can do any kind of swaps for your stablecoin operations or any kind of token operations that you like. Lastly, what we're going to talk more about today, where we work very deeply with the DFINITY Foundation, is on a deep DeFi execution environment and essentially reduce all the kind of risk vectors that exist so that institutions can actually access all the top dApps within the ICP ecosystem. Of course, like security is at the heart of Primevault, and we're SOC 2 compliant, and we're audited by Halbon, which is the top security firm, and we work with top experts to make sure that our security is on point. And we've been building this almost for 2 years, and it's been almost a year since we launched, but we've already got some of the top institutions across the world using us. We've got market makers like G20, trading teams across Arrington, Hashkey. We've got OTC desks across LATAM and MENA like Koiwe. We've got actually token projects launching on us, and we've got a bunch of partners. DFINITY Foundation has been one great partner. We've got Circle, Wormhole, and a bunch of others who've actually come on board to use our platform. But before I get deeper into this, what exactly is Primevault? And I just want to talk at a platform level as well as at the core technology level. One of the key issues which a lot of institutions face is that they work with a bunch of partners across different parts of the token operations, which actually makes it extremely risky in terms of security and causes a lot of overheads. What we have done is we've actually integrated the entire stack together. and abstracted out all complexities. So what institutions can do today is, not just custody their assets on our platform across any chain, but they can use our liquidity pools to do trading or, move money across, different venues or, across chains. We also give them like a deep DeFi execution environment. Another thing which we allow, projects or institutions to do is like automate their token workflows, like tokenization, issuing of tokens, or like vesting distribution, a bunch of different things. And we also allow for like audit and, transaction audit and reporting. One key thing which we've done differently from others is we've actually innovated at the core technology level, which is what we've done is like, Fireblocks and others use MPC. We've actually moved away from MPC and we use TEEs or trusted execution environment. One of the core innovations, what we've done here is that the policy engine for a lot of MPC players is centralized, which means you always rely on a counterparty to sign their half of the transaction. What we've done is we've made this like this, like a lockbox in a bank where the policy engine and the keys lie within the TEEs, which actually makes it more secure. And we also use formal verification to make sure that the policy engine is behaving as it's supposed to do. And because of this, what ends up happening is users are just not signing transactions, but they can actually do intent. So any complex, token operation you want to do can be done within the platform. And because of this, what we've actually been able to do is automate any kind of workflow. It's like a DIY out of the box automation, which you can do. Our signing speeds are much faster than anything that exists within the market, and we're more secure and more reliable. But coming to the core of today's presentation is when we started working with the DFINITY Foundation a few months back, the biggest challenge which was faced was like a lot of the institutions wanted to access the top DeFi apps like ICP Swap, Water Neuron, and others. But there was no clear way to do this. Like a G20 GSRs or banks and fintechs and VCs had no way to access this. So what we did essentially is in the last few months, we obviously added custody support for ICP and all the top tokens. We worked very, very closely with the foundation, Dan, Frederick, and others. And what we've actually done is we've integrated the leading DeFi standards, and we actually set a new whole standard for interoperability. What this actually enables is something big that now going forward, institutions can connect to any dApp on ICP seamlessly. So any kind of use case they want to do, market making, staking, trading, any new dApp which comes into the future, they can just use Primevault to start doing their activities on DeFi without actually doing any kind of custom work. So what the institutional access to DeFi ecosystem looked like till today looks different now. We're actually the first ones to be enable DeFi access to the ICP ecosystem, and I'm extremely excited to be being able to help provide institutions this gateway to all the top dApps on the DeFi ecosystem. And for this, we're actually going to do a live demo where we're going to show how this actually works. So I'm just in the next few minutes, I'm going to show how the Primevault app or the platform actually interacts with a dApp on the ICP ecosystem. So very quickly, as you can see, ICP top-up is one of the dApps which I'm going to be showing how we interact with. So what you need to do is first connect, and you would actually see Primevault in the NFID drop down where you can connect. Once you get connected to our extension, you need to select the vault where you want to interact with this particular dApp. Just give me a second. I'm just going to log in. Give me a second. Yeah. Now, once I select the vault and give me a second, please. And once I make a connection, what you're actually going to see is a delegation request will actually come in. And what I'll go ahead and do is I'll submit this request for a delegation request to be submitted. And what I'll see next is based on the policy approvals, I'll actually get an approval which I need to transact on the phone. And what I'm going to do next is actually show you how this approval looks on the phone. Yeah. As you can see, I would have got a message for delegation or request for this particular dApp, and based on the policies, I need to slide to approve. I do that, it takes my Face ID, and the delegation request has been done. What I'll do next is, I'll just go back to the screen, and now I can actually start interacting with the dApp. As you can see that, the delegation request has been sent. I'm just going to add, quickly paste a canister ID so that I can actually start interacting with the dApp itself. And what I'm going to do is paste the canister ID, choose the top up amount. I'd like to, burn 0.1 ICP. I just need to approve the funds. As you can see, my balance already exists. So I'm just going to send this top up. And once I do this, I'm actually going to get a fresh new request to top this up. What we've actually gone ahead and done is, we actually make the message in a human readable format. So any institution that is interacting can actually see that, this is a consent message, this is a sub account, what this dApp is actually sending you on, the approval fees, the canister interacting with, and I'm actually going to set this for a submit, so that this particular institution which is interacting with the DeFi app can do this. Now, because I've sent this message to be approved, I will again share my screen on my phone and show how this actually looks on the phone. As you can see, I've received a contract call for the ICP top up. All I need to do is, slide to approve. And once I do this, and once it takes my Face ID, this actually will go for an approval message, which will actually be signed and sent back to the dApp for approval. Once I go back to the screen, what you'll actually be able to see is this has actually been done, and the top up is actually happening from our end. So this is like an end-to-end execution where, your top up is happening. While this is getting executed, I also want to very quickly show you on how this actually looks within the platform, where you're actually able to see every single transaction that happens. So once I actually go into the transactions, what you'll actually be able to see is essentially the first one was the delegation request and the policy approvals that existed. And secondly, the actual transaction that you signed. This actually is an end-to-end flow, which we actually just did live on this demo. And this is something which we're extremely excited to talk about. I just also want to very quickly walk you through, some of the things which you're doing for the ecosystem itself. As I mentioned, we're extremely happy to integrate ICP and, be the first ones to do DeFi. Some of the things which we're doing is we're working with market makers, OTC exchanges, institutions to enable, DeFi on ICP for them. We're working with token projects, fintechs, payment providers, and dApp builders. And we invite everyone to actually come on and, use Primevault for the DeFi activities or custody of the, ICP tokens. Something which we're extremely excited about is we're actually giving an exclusive offer for the ICP ecosystem. Multiple other players, MPC players like Fireblocks and others are, they have their various starter prices and they give outgoing volumes of a few 100K and some workspace users and some limited exchanges. What we're doing is we're actually not just competing on price, but we're actually trying to give a bigger bang for the buck. So we're actually allowing you for millions of dollars of outgoing volume, 5 to 10x more like workspace users and blockchains and like exchanges. And we're extremely excited to be the first ones to be implementing DeFi on ICP and enabling institutions to access all the top dApps on the ICP ecosystem. Thanks, Sam.
Cool, thank you. And with this, we are right on time. We had a very packed hour. Greetings to Belgium, where we see the Aviat Lab team. It's super nice to see you all. Yeah, we are at the end of October. Happy Halloween, and see you at the end of November. Thanks for joining today. Bye-bye.